طيب إذا انتهينا بخير في عندنا مجال الأسئلة. في عندنا أسئلة كان دور طويل. بسم الله الرحمن الرحيم. Okay. We will start with this title, Elasticity. Of course, the word elasticity coming from the word elastic. Right? This is the adjective of elastic. Who can tell me what the word elastic means physically? Stretch. Yes.
The ability to stretch.
The ability to stretch or compress. Okay? This is correct. Now this is it. Now the idea. If I give you two things, if I say, for example, spring, we can claim that the spring is elastic because easily can stretch or compress. Similar also that rubber band. Rubber band is also elastic.
Yeah.
What about the steel bar? Is it elastic?
No. It can when you're heating it up.
No, we do in normal conditions. No, it is elastic.
Steel bar.
Yes.
How?
I will explain it. Now ask yourself, Ernie, that spring is made of steel, right?
Yeah.
How that spring is elastic? Even it is made by steel, and the steel bar is elastic.
The shape
Is that the
of
point? Yes, the shape is has, but in general, let me tell you something. Gentlemen, we don't have something called by inelastic. All the materials, they are elastic, but they have different degree of elasticity. That means they show different behavior. That means if you apply a force on the spring, that spring will change its shape, will deform higher or greater than steel bar.
Yes,
Is that if you pull, gentlemen, if you pull that spring, it will deform. Deform, that means change its shape easily and linear. If you pull that steel bar, it will also deform. But that deformation is undetectable for us. Just like, let me show you something. You cannot see it. Now, ya shabab, if I pull this, I stretch this one like this. Is it change?
No.
No, but no, it is. There is some changes.
But we can't see it.
Yes, it's as we said, it's undetectable for us. If you have the proper tool to see that, if you have that microscope or something, you can see inside, oh, the particles or the atom, they move a little bit further from each other.
Yeah.
There is a stretching. Alaykum salam. So, ya shabab, to be general, there is nothing to be said that something inelastic. All the objects, they are elastic. But some objects, they have different degree of elasticity. Some of them, they have a large degree. Yes, they actually, they affect by the force higher or greater than other objects. Okay? Let's go to the following. See, Ishmael. Now I will show you the following. Here, every solid object stretches, compresses, or deforms when a force acts on it. I said every solid, not most, not some. Every. If you stretch a rubber band, there is a force that tries to pull it back here, that rubber band to back to its equilibrium. Of course, I will show you this one. Now we talk about elastic object. Now suppose I have this rubber band. If you just simply stretch it and release it, it goes back, just like a spring. Okay? That force we call it by restoring force, which is here قوة الإعادة مش here. That restoring force is something natural, and this force is already generated inside the rubber band, not in my hand. So let me show you something. In case, gentlemen, of springs, if you have a spring like this, and what you do, you just simply pull it down. This is external force applied by you. I mean that restoring force is already generated inside the spring. That force, where it is? Up. I will call it SP. SP stands for spring. This restoring force, gentlemen, it's always here. It always retains that object to its equilibrium position.
Okay.
Just like here, if you just pull and release, it will go back. Okay? That force. So Now this is here, external force is applied by you. And this force here will cause what we call by displacement. You displace the spring,
Okay.
right?
Okay.
And when you displace it, there will be. And you should notice the following also. That displacement, gentlemen, is direct proportion to the restoring force. Just like, see, if you just displace a little, restoring force will be a little. Like this here. This a little. If you displace a lot, restoring force will be
Higher.
much more higher, right? I remember in school time, sometimes we use that rubber band too much.
Yeah.
If someone is actually your close friend, if you want to just hit him with that paper, you just stretch it a little bit. So it's very soft.
Yeah.
But someone you hate him, you stretch a lot, right? We control this. We apply this, by the way. So, gentlemen, more displacement, more restoring force. Is it okay?
Yeah.
Now, let's mention restoring force, the force that restores a system. The system that exhibits restoring force is called by elastic, just like, gentlemen, springs, rubber bands. You can say any kind of these.
Okay.
Now, I need to say, if we just, gentlemen here, try to find the relationship between this, you should know the following, that as displacement increases, restoring force always increases.
Yeah.
So they have a linear relationship.
Direct proportion.
Yes, they have a linear. When I say linear, that means they are directly proportional. So what happened in this one? We can write FSP is direct proportion to delta X.
Okay.
Gentlemen, this sign it shows a proportional sign. If we want to replace it with equal sign, we should put something called by the constant of proportionality, if you heard about it.
Okay.
This is a sign, it's a proportional sign.
Okay.
If we want to convert it into equal, we have to add the
Constant.
constant. It's called by constant of proportionality. Now, ثابت التناسب يا شباب. This constant, gentlemen, here, we have it, it's called by K. And it is a constant. I'm sure that you took this before because you studied Hawke's law before.
Yeah.
That K is a constant for every individual spring. And it is called by spring constant. It's not changing. For every spring has its own K value.
Yeah.
Okay? And you should notice the following also. These, that F spring and the displacement are both vectors. And they are always acting opposite to each other. So if displacement downward, restoring will be
Upward.
right. If displacement to the right, restoring will be
Downward.
to the left. This is what we say. So always they are opposite in direction. That's why I'm gonna do something also. I'm gonna add here negative sign. Is that clear why the negative sign?
Yeah.
It shows only, gentlemen, that the direction of displacement is opposite to the direction of restoring force. Okay, let's proceed now here. The last sentence, gentlemen. Elasticity and restoring force are also properties of stiff system. Stiff, that means here الصلبة يا شباب. Such as steel. I told you steel is elastic. Not all the solids are elastic. Glass is also elastic, but it has very, very low. Gentlemen, when you say in science, if you say something like 0.00001, it doesn't mean this is not exist. It's there, but it's very low. You got the point?
Yeah.
Sometimes, gentlemen, when you deal with the, for example, mass of electron, did you know that the mass of electron, see, 9.1 times 10 to the power negative 31 kilogram. If you want to write this number, Zaid, you write 0.30 zeros, then 91. Even though they consider it, you cannot skip. You cannot say, oh, this is 0. You figured out how is it, يا شباب?
Yeah.
30 zeros you have to write. 30 صفر بعدين تكتب ال9 هذه. Even though it's considered. In science, we cannot skip. We cannot say, oh, that's very low. We can ignore. No, we cannot skip here. Yes, sir.
Do other planets have effect on us in terms of gravity?
Yes, they affect it, surely. We have the sun, we are affected by the sun. We are orbiting the sun. And we have effect by the moon, high tides and low tides. right?
Oh,
There are
I
this
mean,
is
yeah,
friction.
what
It's
about
there.
other planets?
Other planets, I think that effect is very low, not that much,
Okay.
but it's there.
And if it's like just non-existing, we will affect it.
We actually, in sometimes, see, scientists, they consider everything. But in normal life, in public life, sometimes what you do, they just ignore these very small values. Okay? And if you ask somebody from actually in public people, what is the mass of the electron? You say, no, it's almost zero. So they have no mass. But for science, you can't say it's no mass. It's 9.1 times 10 to the power negative 31. You got the point how they look? So this is the idea. طيب يا شباب. Now we are here. Let me tell you something. We have the human bones and twigs of tree. Twigs of tree, you know that they have different elasticity, أغصان الشجر,
Yes.
so
Yeah.
they can simply. Now the human bones. Did you know that there are many types of bones and what we call by that tissue? There is what we call by very rigid bones, just like in your upper leg here. And because this has a function, it will lift your other weight. So it's very strong, it's called by cortical bones. Okay? There's also another bones inside it, it's called by the spongy bones or cancellous bones.
Oh, yeah.
This is something different. You will study this. What about this gentleman? This is a kind of bones.
Cartilage.
That
Cartilage,
cartilage,
yes.
yes. Cartilage is also a kind of bones, but it is flexible.
Undeveloped.
Because we have a problem. If it is very rigid or stiff, so if you've hit the door or the wall, you have,
It's gonna be broken.
yeah, you figure it out.
Yeah.
All of us will have this problem.
You can't sleep.
Yeah, alhamdulillah, you can't sleep on it.
Oh, yeah.
That's another problem. So this is, now, ya shabab, this is the idea. We have this different. If you compare between the cartilage and the bones, we can say they have, even the bones in men, they have a degree of, we can say, elasticity. You can't bend it. You know, when two people, they fight with each other, somebody hold the hand and he just simply try to bend the hand, okay? To tap out or whatever is it. This is a kind of, also try to bend here or apply, there's a kind of elasticity. If he can withstand that pain, he will never give up, right? Otherwise, he will give up. And simple, we have this one. We can do it sometimes. If you just hold the hand, if somebody pressing your hand,
Oh.
if you can simply fold this one, it's okay for you. You can, never mind, nothing happened to me. Otherwise, if it is very tough for you, you pull your hand. This happens, yes. And this is how the life. Okay, Shiva. And we can say also, before we proceed, different people, they have different elasticity in their bones. Some people, I saw this before, they can simply put their legs up on their shoulders. Can you do
Yeah.
that?
By training.
By training, yes, by training. But we can say also they have different elasticity in their bones. Some people, they can stick themselves inside this very small box. You saw this, I think.
Contortionist.
Yes, they have that elasticity is just different. Okay, Shiva. Now I'm here. Just one. Here, this is the relaxed spring, unstretched. As we said, if you compress the spring, what happened to the spring constant will be the opposite direction. If you stretch it, that spring constant will be in the opposite direction. They mention here, the restoring force always point in direction opposite to the displacement from equilibrium. The value of restoring force depends on the value of displacement. More displacement, more restoring force. And this is clear, how hard the spring pulls back depends how much it is stretched, more or less, okay?
Okay.
According to these two, if this is the spring constant, this is gentleman here, we draw, and this is my delta x.
Okay.
The line will be straight line, because we say they are linearly proportional, right? If now, from this one, we can find, gentlemen, the slope to be the value of k.
Yeah.
Because from the formula, k here is equal to what? Restoring force over displacement, صح يا شباب?
Yeah.
So this is simply, you can write يا شباب here, k is nothing but the slope and is equal to restoring force over displacement. restoring force over displacement. This is how we find. Now I will give you some ideas about these, but let me continue because there will be some questions on these. See you, Shbab. Now this is the rest of the idea. We said the spring force is proportional to the displacement. We write this one, and we explain here. We say that this K is called by spring constant, is measured in Newton per meter, okay? Because in Newton for the force and here. And here, we have this negative sign. See what is given in the book. Negative sign says that the restoring force and displacement are in opposite direction. That's it. This is, they are always in opposite direction. Now I have an idea. Gentlemen, we have, according to this here question, what are the different type of question they will give it for you? I need to say something. We can write, gentlemen, here that F spring is equal to minus K, X final minus X initial. It's not necessary to give you always the displacement. Let me say something. If you have a spring of length 10 centimeter, you stretch it, and its final length becomes 15. So delta X will be 5. The difference. I see. It was a Z 10, then it becomes 15.
Yeah.
So how much delta X? Yes. Okay. And if you have a spring of 10 centimeter and you compress, it becomes 6. How much delta X? It's 4.
Yeah.
Yeah, it's minus because it's compressing. Okay, Shabab, this is what we call by the change in length. This is one thing. Now, this negative sign, gentlemen, it shows only direction. I advise all of you here in problems, we just ignore it. And we take this is always positive. I will tell you when we solve some problem. Now, sometimes also is it here. We give, sometimes they will ask you like this. This is, if you draw this one times this one, we have the line. So in one problem, I will give you the following. Suppose that delta X of a spring is 10 centimeter, and this is the values, say 1, 2, 3, this is say 10, 20, 30. Can you find, for example, F of spring? I gave you both these.
Ah, okay.
Yes, you can find it.
Yeah.
Because this is delta X is given, and from the graph we get what? K. K is what?
Slope.
The slope, yeah, it's easy. You can know
Yeah.
that. Change, actually rise above run. Changing
Yeah.
y-axis over changing x-axis,
Yeah.
right? And from the x and k, you can find what?
Yeah.
The spring constant, that restoring force.
Yeah.
Okay? This is an idea. Is that idea clear?
Yeah.
Right. Now something more. See here, Shibra. Sometimes I will give you 2 springs, not one, with different, of course, straight lines.
Okay.
This is spring A and this spring B.
Okay.
I will ask you, which spring, that's very simple question. Which spring has a higher K value?
A.
Of course. And this higher, say, K value we call by stiffer. And the lower we call by softer. Because if you compare between 2 things, someone is stiffer than the other. Okay? Means, ya shabab, stiffer has a large K value. As K value increases, that means the stiff is the spring.
What's an increase?
Yeah, it's going to increase. As the K value decreases, you know,
Then we have
that
softer.
is softer. And gentlemen, we have different types of springs. Did you know there's some spring, toy spring, that's link springs.
Yeah.
They use محلات أبو ريالين هدول.
Yeah.
You know that this is very soft. It contains that we can say K is used is very, very low. Why the spring is used in your cars in that shock absorbing, this is very high.
Yeah.
Correct? Because this designed to simply to lift the weight in your car.
These
That
are
one
tons.
has no weight.
It's a toy.
It is a toy.
Yeah.
You got the point. By the way, they have the same concept, the same shape, but they have different K values. Okay? And the last thing here, Shabab. Here, this spring and this spring, since they are straight line, they obey Hawke's law because this is called Hawke's law. Hawke's law states that the relation between F spring and the delta X is linear. When I say linear, that means straight line. If it is a curve, that means it is non-linear. You cannot apply the here,
Okay.
yeah, because when I say linear, you can predict the values.
Okay.
How you can predict? If I say this value 1 and this is 5, so the other one will be 2 and 10.
Ah.
This is the value.
Yeah.
I'll give you only one value. Then 3 will be 15, and so on. You got
Yeah.
this way we predict the value. It is linear. Linear means they both change equally.
Constant.
Yes, they change equally. But sometimes, if it is a curve, it's non-linear.
Okay.
Right, let's go to the question. Now I will show you some questions. Now, this is the Hawk's law, as we explain it. And, gentlemen, we have two different springs with two different K values, okay? Which of them describe the stiffer and which is the softer?
The bigger one is the.
لا تعتمد على الصورة. نبغى. Surely أنا بجيب لك واحد كبير جدا وواحد صغير جدا، الصغير أقصى من الكبير. No, stick with what K value. What we say, high
No.
K value means stiffer, صح؟
Yes.
الله يرضى عليك. This is what we teach. لا تعتمد على الصورة يا شباب. You don't know. You don't touch it.
But even if I don't have
No,
a K
no,
value.
no. They may give you different K value. You have to stick this with this. يعني لازم ترتبط بهذا. عاد يمين. Low K value.
It's soft.
Softer.
Yes, is softer. Like this we answered. We don't look to the picture just to show you. طيب. In the second question, gentlemen, the restoring force of three springs is measured as they stretch. Which spring obeys Hooke's law, A, B, or C?
All.
بارك الله فيك. Yes, all of them.
Yeah.
Because all of them linear.
Yes.
Okay, that's right. All of them. طيب. والله يا شباب, there will be some question with these. Which spring has the largest spring constant? Because K. Because K high, when I say K high, because we say that it's the greatest slope. Is that right? And please don't tell me why this is. You know that slope here is steeper compared to the C.
Yes, different.
واضح? And this is we have K low. We have the lowest slope or gradient. This is what we.
Okay.
That's it. So that K value, gentlemen, some other books they call by, instead of spring constant, they call by stiffness constant. That means it's as the K increases, stiffer is the object or the substance. And as K decreases, softer is the substance. Okay? This is sometimes too. So, is that clear for you? If it's clear, let's go to the questions. Now I'll give you a new idea how to solve these questions, because they are straightforward, these questions, but we are not going to stick with the same style of the book. I'll read here. A scale used to weigh fish consists of a spring hung from a support. The spring's equilibrium length is 10 centimeter. I'll put a line below.
Okay.
When a 4 kilogram fish is suspended from the end of the spring, it's stretched by a length 12.4. Who can tell me what is 10, what is 12.4?
10 when it's equilibrium.
Okay,
And 12 when you stretch it.
so give me some symbols.
So
X,
delta
Y,
X, it's only, the 12.4 is X2.
Allah يبارك. Right, you're right. Both correct. So XI is 10 and XF is 12.4. So delta X,
2.4.
yes, barakallah. Barakallah. Right, that's correct. And we should times by 10 to the power negative 2, gentlemen, to convert to meter. Okay, we have the mass. How much is it?
4.
Okay, I will write the formula for you and tell me, now you tell me how we solve. This is F spring. I'll tell you there's no need to write the negative sign. Times delta X. They will ask for the question, sorry, I will show you now. What is the spring constant? K will be F spring over delta X, right?
Yeah.
طيب. Delta X is there. What about F spring? يلا يا شباب. تضربها في الوزن؟ هي نفسها الوزن.
Yeah.
M
Right.
times D.
I need to see يا شباب. This is your, by the way, this type of scale was used in the previous years. This is your fish. See, you have two forces acting because you hold it like this. One force is acting downward,
Wait.
and another force is acting upward, which is a restoring force, right?
Yeah.
And since it is in equilibrium, that means these two forces are equal.
Yeah.
What you will do simply, you replace F spring by the weight.
Yes.
So I'm going to write, gentlemen, here, mg over delta
X.
x. And we can apply that k, gentlemen, is equal to 4 times 9.8 over 2.4 times 10 to the power negative.
Two.
And the answer will be 1600 Newton per meter. Okay?
Yeah.
طيب يا شباب. Please don't take care about, care just only about, don't care a lot about the science. I will show you now how the textbook they solve it.
في احتمالية يعطينا في السؤال الويت ما بالكيلوغرام يعطينا الويت
يعني جرام
يعني ما يحتاج نضرب على طول
يعني ممكن إذا أعطاك just convert from gram to kilogram. No, you should convert. طيب يا جد. يا شباب. In the second question here, I'm sorry, I will show it to you now. If an 8 kilogram fish is suspended from the spring, I need somebody to answer this directly. What will be the length of the spring? Yeah. You don't have. You can do it by yourself. B. If instead of 4 kilogram, we replace it by 8 kilogram.
It will be the double.
So give me the answer. How much the length? How much? X final.
14.8.
Allah يسعدك. Right. Did you know? This is what they ask. How much? Not the length. They're not asking how much the extension or change. How much the length? They ask.
Of the spring itself.
It's 14.8. Let me explain this for you. How is it? In 4 kilogram, of course I will show you how we, in 4 kilogram, the original we have 2.4 centimeter, right?
Yeah.
In 8 kilogram would be how
It's
much?
double.
It's a linear, we said that, it's a linear Z.
Yeah.
We say when a linear you can predict the next, صح? Okay, 4 point. The original length, how much is it?
Step.
So add this to this, so it will be 14 point. This is an idea. Or, see ya shabab, in this way you save a lot of time, if you look. Because we know that this is, we say linear relationship. Otherwise, you can say, oh, in this way, I'm gonna say F spring is equal to K delta X. Again, F spring now is mg. How much m in this case?
It's
8 instead of 4 equals 1600. Can we use 1600? Yes, this is constant. You can use it at any time. Times, gentlemen, what? Delta. If you find delta x, I'm sure it will be here, in this case, 0.048. That means, and you add it to the here. This is how, but I prefer this one.
It's much faster.
Yeah, it's much faster, it's easier. This will save a lot of time for you, Ishra. Because I mean, you rely on the idea. The relationship is linear. That means you can put the values and you predict the values. Yes.
But it's doubled.
Yeah. It's doubled exactly. Yeah, this is good. طيب يا شباب, is it okay for you?
Yeah.
واضحة بارك الله فيك. Gentlemen, see, in the textbook, this is the solution. والله ما نعرف how they solve it, but see, negative. Don't care about it. I need to say something. Always, you skip that negative sign in the formula, and always consider delta x as positive. So positive here will be always the right. Inshallah ta'ala. طيب. If that's clear for you, let's go to the next question. I will raise here this one. See you, Shubha. Now, in this question. It is mentioned that several companies manufacture running shoes that have a thick heel pads containing steel springs to launch the runner back into the air after heel strike. Let me explain an idea for you. Some people actually doing that kind of sport is running marathons and races. They use a special kind of shoes. These shoes, they are designed to contain some springs in their pads, in their heel pads, okay? These springs, gentlemen, when they step on the floor, they will compress the spring. And the spring, what happens? They will switch again. So they push that runner to move faster. Of course, indeed, we can say this is very costly. They pay for it. You cannot find this is in the market cheaper. It is something, you know that, these special kind of shoes. The idea was these springs, they are using for this to give some, to just like, for example, we have, for bicycles, we have the bicycles used for mountains. You know that, these bicycles with the shock absorber. It's very costly also. We have also bicycles for racing. It's very light. I see many people, they can simply lift it in one hand, that bicycle. But they use the bicycle in the market is very heavy compared to that one. You see the difference. So this is, all the people, they paid for it. Now, let's go to the question. This is an idea. What is the gentleman here? We have containing vats. When a 70 kilogram runner, we have the mass. 70 kilogram. Rock back on his heel so that all of his weight is supported by the heel springs. The springs each compressed by 1.2 millimeter. I need somebody to tell me, what is this 1.2 millimeter? It's delta X, barakallah feek. Yes, I will write directly 1.2 times 10 to the power negative 3 meter. Is it clear?
Yes.
We always use meter. Now, tell here, okay? Pay attention. I will stop it here and I will give the first question. What is the spring constant of a heel spring? Okay? We can apply this. I will write here the formula. K equal F spring over صح? طيب. Delta X is there. What about the spring? F spring?
The weight of the gravity.
It's mg. Okay, Shabab. Right. But we have something. Tell me why it is half. Yes. When we see the question, Shabab, let me explain this. Actually, when you step in your shoes, your weight is divided. Half of it in one shoe and the half other shoe. When you run, always you actually use one of them.
Yeah.
Because you left the other. So he mentioned here, Ishbab. Now the spring each compressed. When here, each compressed. What is the actually spring constant of a heel? A heel, that means one of them, not on the both heels. على كعب واحد مش على الكعبين, right? That means we assume that heel, Zaid, left how much? Half of your weight, not the whole weight.
Yeah.
You got the point, ya Shabab? So that's it, nothing there. You just apply this one. Will be half times 70 times 9.8 over 1.2 times 10 to the power negative. And we just find it. Okay, barakallah. طيب. Please just pay attention because this is here. From here, there is another idea. Sometimes, if you understand the question, you can easily deal with it. Otherwise, it will be really tricky questions. To be honest, if I give you the question, this question, all of you, you will never consider half of MG. You'll consider MG. To be honest, this is the, but see how this is the ideas that we care about it. That's why we issue them. In our midterm exam, there will be only 15 questions, not 40 or 50 like biology. Because we know that 15 questions contain a lot of tricks, more than these, that biology exams. This is your job. Read the question carefully. Because in physics, every word has a meaning. You should translate that from English to physics. Now, see, when he is running hard, this is mainly happened at the end of the race. He tried to run very hard and hits the ground on one heel also. The force compressing the springs in this case is 5 times his weight. Okay? This is another case. Can we find, gentlemen, in this case, by how much, I'll raise this, by how much the spring compressed during a heel strike? During a heel strike.
Yeah.
A heel, not heels. Okay? A heel. Now heel, you figure it out, gentlemen, in the marathon always, these people, normally they run, we can say quietly, softly at the beginning. At the end of the race, what they are, they run so hard, right? At that time, that heel, we can say they apply more and more forces on that in compressing these springs in their shoes. So how much the force is about 5 times his
Weight.
So if we want to find delta x here, gentlemen, we say delta x is equal to F spring over K. K we got from A. This is constant. Now F spring is 5 mg. Aywa, times half.
Yes.
5 because it's given. 5 times the weight. Okay? And why is that? Because it's a please a heel, not heels. Heel that means 1 over K. And this is all of it. Is it okay for you, Hi Shabab?
Yes.
This is the second one. Aywa. Now, let's be done. This is the last slide, and then we will. This week you have a, I think, read and ethic exam.
Yes.
This week.
Yes.
Tomorrow?
Tomorrow,
And next week.
Chemistry.
Okay. Okay, gentlemen, this is just on an idea. I will explain stretching and compressing materials. Every solid here, material, I will explain it here. We can model most of them in solid material, just like the steel, as being made up of particle-like atoms connected by spring-like bonds. You can imagine this, you can figure it out, that the material, even this, is made of simply atoms, and these atoms connected by springs. When you simply stretch the material, you stretch the springs between them. So the material actually elongate, increases by length. When you compress what? The springs between them, and the material, it will shorten in length, right? This is natural things that we have it. And this is, you know, this having, this you cannot see by your normal eye. You need that microscope, or as I said, the proper tool to see. You got the point? This is inside the materials, how these atoms connected by the springs. We cannot see this by our. That's why if I say the following, can I see now the change or deformation in this rubber? Yes, I can see. This is elastic, okay, with a large degree of elasticity. Why? If I do this with this marker, I stretch. Can I see something?
No.
No, it means there is nothing there.
No.
There's something, but we cannot detect. We don't have the proper tool to detect that. In our normal eye, we cannot see it. Okay, but it is there. So this is, gentlemen, in the engineering field, they call by the cracks, how the cracks and the cracks growth. Because always, when any part of anything that fell, it starts with a crack. That crack starts growing. After some time, it has what we call by the failure, breaking, or that notching.
Okay.
This how happened. Nothing actually occurs directly. There will be some crack, the cracks becomes bigger and bigger and bigger till that whole substance fails. This is the idea. Let's go to these 2 questions. What happened to the particles of the steel rod when the rod is stretched? The particles move towards each other or away from each other?
Away.
Okay, so we say that particles simply move away from each other. This is the idea. from each other. Okay, now I will introduce something for you. This is important, I think. Steel is elastic, although it is called rigid. You know the word rigid in English?
Yeah.
Solid.
Solid. Material, explain that. Gentlemen, yes,
Its elasticity is very low.
yes, we have to connect with something. It's elastic, there's no question about that. It has a large K value, and it has a very, very low deformation. Deformation معناها تشوه في شكله. فعلا أنا لما شد هذا ما تغير شكله. ولما شدنا المقطع إيش شكله؟
غير.
Okay, so we simply I need to introduce this word deformation. Deformation means change in shape, because not necessarily, gentlemen, always we have a change in length. We can sometimes change in shape. صح؟ طيب, so we say here rigid, high K value, and gentlemen here, low deformation. Please be careful about this word, low deformation. Now, the other substances, just like the rubber bands here, they are called by pliant. The pliant is the opposite of this, low K value and
High deformation.
yes, and high deformation. High deformation. That's it, ya shabab, for this. And please, you should see something. We have elastic and plastic behavior. ركزتوا what is the difference between these two words, elastic and plastic.
Yeah.
Elastic, gentlemen, they retain to its original shape because they are elastic. In plastic, no, they have a large deformation. بتشوهوا على طول. Okay? So they are closer to each other.
Okay.
Here we apply the same thing. Why? Because sometimes you are, as a physician or something, you can try in materials. These materials you can put inside your patient, so they are should be elastic, should contain some also some properties that preserve or be safe for your patient. This is what we say, that we concern about it. Right, I will stop here regarding, because the last here I will make it with the next week, with the next lecture. Let's go to the questions, because we have about 10 minutes. Okay.
كذا نصور.
Shabab, we try to finish this today. It's only 15 questions. But remind me, we done these questions, we solved it last week.
Yes,
حليناهم.
we did.
No, 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 no.
هذا حليناها هلا.
بس واحد
حليناها 5 أسئلة. اللي
Never
تحت
mind,
فوق.
never mind. We solved it. I'll be fast in this. انتبهوا معي بارك الله فيكم. Gentlemen, we have two vectors, B and Q. Which one of these, or in here, said actually represents the vector sum B plus Q? C. Of course it is C, because how you just, you remember that tip to tail? You can stick this here or stick this here. If you stick B here, this is your B, so this is will be your B plus Q. The answer would be C. Now, what is the answer of question 2? You have a vector and you have two complement angles. Complement being their sum is 90 degrees. And in mathematics, we know that sine 30 is equal to cosine 60.
Yeah.
Because 30 and 60, their sum is 90. They're called complement. If their sum is 180, it's called supplement.
Okay.
في العربي بيكتبوها اتوقع عشان متكاملة أو متتامة. You got the point. Now, according to this, they ask you, what is the x component of the vector E?
C.
طيب, let me say, with respect to theta, x is what? Adjacent. صح?
Yeah.
It's cosine. I will write this for you, Shabab. It's E cosine theta.
Okay.
And T.
minus.
Of course, it's minus. With respect to phi, that y is cosine. So E x will be,
Sine.
but it's not theta, it's phi. And it's both negative.
Why it's 5?
Half.
With the y it's
Y it's cosine. But he asked for what? X component.
Yeah.
Yeah, Shabab. Of course, they are both negative because we know that in second quadrant x is negative. So the answer is one of these, either minus e cosine theta or minus e sine phi. What is your answer would be?
D.
It's D. Okay? It's e equal to minus
y minus y minus.
Because it's in the second quarter.
in second quadrant. In second quadrant, I mean, we are not going to explain this here. X is positive, y is positive, this x negative, y is positive, this positive, both negative, and here x is positive and y is. Got that? So this is what we do. Okay. Let's see the questions. This is a very good question, really, and we took the same idea. We have, gentlemen, three quantities: position, velocity, and acceleration. See the motion diagram, the signs of the position, velocity, and acceleration. I need somebody to answer. Yes, tell me. What about the position?
The position is negative.
Yes. Velocity,
Velocity positive.
acceleration.
Negative.
First of all, this is negative because this is your
Position.
reference point. It's
Yeah.
below it.
Yeah.
Now V is positive because it's where? Up. And A, this is free fall. A is always
Negative.
negative. Okay, so the answer will be D also. واضحة؟ طيب. Let's go to the next question. Here. Iba starts from position 22 along coordinate axis. She's then undergo displacement of negative 35. What is her final position?
See?
It is C, right?
Yes.
Can you tell me how you find it?
Because he said she starts a position at 22 meters along a coordinate axis.
Yes.
And she undergoes a displacement of
Negative 35. So this
so
negative 30 will be in which direction?
on the
Left.
left of yeah.
See it, Shabab. Your answer is perfect. I need you, if you want to say something, all of you, you draw. I'll draw the line of numbers, okay? This is my 0, so this is will be 22. Now, Heba is here, okay? Now, they told us here in the question, she moved actually make a displacement negative 35. According to negative means to the left. So this is negative 35. If I say negative 35, we need here, she covered negative 22 from here to here. So how much from here to here?
13.
Allah Barak fikum. That's it. Because negative 30 and negative 22 is negative 30.
Fine.
This is how you convince yourself first. You answer perfect. Did you know something, gentlemen? يعني هذا يا شباب. In exam you feel that these questions are so hard. You see how much this question easy. If you had the same mentality when you solve the question, just like what you have it now, Allah, you see that you can nothing. Just like that you can answer it. But the problem that stress and tension in exam, this is the problem that you can affect all of us. طيب يا شباب. A bird accelerating from rest. This I am. That means Vi is equal to 0. Experience a displacement and the time t. What is the acceleration? I'm going to tell you directly. We have delta x is equal to VIT. Don't worry, this will be given for you. This formula.
Every question,
The same thing. Yes, sir.
every question have his formula, or in just
No,
one sheet and we need to
the
pick
formula
up.
sheet. We'll give you all the formula. You can take what you need on it. Because, by the way, I will solve by one step. Maybe somebody else, he solved in 2 steps. So he needs 2 different formulas. He can use anything. All the formula will be given for you, and it's your choice. You pick up which formula will. So, yeah, Shabab, when you receive in the midterm exam, first of all, the formula sheet will be in the last page. You just read the page and put it in front of you. That's the formula sheet. شيل الورقة هاي تحطها قدامك ورقة القوانين. Always.
دكتور والتحويلات بعد
التحويلات يا شباب, see, anything out of normal will be given for you. لكن تحويل سنتيمتر أو مليمتر no. بس in case if we give you mile, inch,
مثلا انش
slug or whatever, this will get that conversion will be given. طيب يا شباب, is it okay that one?
Yeah.
Yes.
Nothing there, everything is there. طيب, let's proceed. Question 6. Okay, who can answer for me? We try to finish all of this today.
D.
It is
B.
D or B?
B.
B, it's B, right?
It's
B would be-
Because E is going down and D is going down.
Yeah, Shabab. Here, let me hear. Of course, the point B, I will show you something. I'll give you an idea. We have a curve, and the curve has no slope. You got the point? How we make the here, the slope for any particle point, we draw something called by a tangent, gentlemen. How the tangent, the mass, يا شباب. تعالوا نقول حاجة. At point A, this is the tangent. At point B, this is, and this is at point C, this is a tangent, and this is also tangent, and here this is a tangent.
Yeah.
Tell me, which tangent has no slope?
B.
B. It's horizontal. Okay? If you can figure it out, okay. Otherwise, draw the tangent at particular point. In that case, you can find always the slope. طيب. Now, in the next question, I think I explained this question for you before. Which of the following graphs represent uniform motion?
A.
Why it is A?
Because it's
XT.
XT graph.
Allah is right. You remember uniform motion, 3 definitions. D constant, A 0, and XT graph is straight
Straight
line. So here, see, this is A, V, X, so this is the answer. And one more point, if I give you also that this one like that, it's also here, uniform. Because gentlemen, here we know that velocity is constant, sorry, is 0, and 0 is a number. So don't even think about it, that the velocity or 0 is nothing. No, it's a number. So even if velocity is 0, it means that velocity is constant. Yes, sir.
Question about A and T straight
No,
line.
nothing.
Isn't it V0, V constant?
This
No,
A
no,
is
no.
not constant.
No, no. The other one.
This one
D.
is, yeah, but they are not asking. Here A, yeah, here. A is constant. A is constant, not V.
Not
Be careful. A is constant, not V. When V is constant, A is 0. But when A is constant, V is not necessarily 0. Okay? طيب يا شباب. Of course, these 2 questions, I will just take the details, nothing there. يلا شباب, you go with me. A ball is thrown vertically upward with a speed. What is this? VI. Okay? How high does the ball rise from its point of release? So how much VF? How much G? We ask for delta Y. Okay? So we know that VF squared, we at that time 2A delta Y. I told you, Shabab, that time all these questions are important.
We have the formula.
No, we didn't solve anything because I didn't know that you have a good idea for it. Oh, you have VF, VI, and you have A, so you can find what? Delta Y. In the next question also, gentlemen, a ball is thrown straight up with a velocity plus 10. Ignoring air resistance, what will be the velocity of the ball when it is fall back into the same point? It is
Negative.
Barakallah feek. If it goes this one, in this level, it's up, so we say it's plus 10. When it goes back, It's
Went
negative.
down negative 10.
Yes. Let me say something. تفضل. What's your question?
About the 8th question. I use it minus 9.8.
Yes, always minus. Always. Yeah. Because this is upward. You just see. Now they ask for y. Okay? So you should use it minus. And you send it, this is minus. Here it will be positive. Okay? And you continue. Now, gentlemen, I need to say something. These two situations, they have the same speed or the same velocity?
And same.
The same
Speed.
Yes.
Speed, yes.
Not the same velocity.
This velocity picks up when you go down.
Yeah, Allah يرضى عليكم يا شباب. انتبهوا. They have the same speed, right? The same speed, that means both 10. But not same velocity. Because one of them up and one of them down. ديروا بالكم. Plus 10 and negative 10.
Okay.
Just sometimes this is the kind of tricky questions. They ask you, in both cases, they have the same. They give you speed, velocity, oh, blah, blah. You just how to explain it. Okay, Shikon. We'll try to finish all of it, okay? 5 questions left. Next week, I'll give you another set. Okay, Shikon. In this question, let me here. The motion diagram of an object moving in a straight line as shown. Which of the following shown velocity versus time graph match the motion diagram? Of course, if you talk, I will say it is not these two.
It's going to the left. So it's down.
It's a negative direction.
Yeah.
Is it okay?
No.
It's D.
So what is that? What is the answer?
D.
But this goes downward. That means the
You don't let the
velocity.
signs.
Yes, yes. Barakallah feekum. It starts here, Shabbat. It starts at negative 10 and end up at negative, say, 60. 60 is greater than 10.
Yeah.
Negative, leave it. Okay, this is what happened to the speed increases, right? So why it's negative, we know that. Right. Now in the figure, see how much these figures are important for you. Position time graph are important. A lot of figures there. Now the figure shows the position versus time graph of a particle. The velocity of the particle at 60. How much is it? How we find it?
Negative
Gentlemen.
10. X, yeah.
Why? Is it that much to go?
No, it's not hard.
It's
Yeah, Shabab.
And
This
last-
point,
Last equals.
this point belong to this line, right?
Yes.
From here to here.
Yeah.
Is it okay?
Yeah.
So,
So we find this
now the slope here is the same slope line. Let's go find this one. This is a positive, by the way. This is your here rise. This is your delta y, and this is your delta. Yalla ya shabab. It's going to be 0 minus negative 10 over. Here we have 80 minus. So it will be 10 over 40. It will be 0.25. And this is the answer. We made a mistake or what?
Yeah, you change minutes.
I said, sorry. No,
Should be half.
should be.
Ah.
No. Shabab,
Zero.
it's so. Oh, it's no. Sorry, it's from here. I made a mistake. Right. 20 over 40, right? So it should be half. And this is indeed, it's positive because going up. Okay, Shabab? Shabab, in any case, if the point here, the slope of the point is the same the slope of the line. So don't panic. This is a point. You find the slope of the line, whole line is the same as the slope of that point. Okay? طيب. Here, the question, I think we solved this question before. An object, gentlemen, here. We have the same question in the slides. You remember?
Yeah.
I think the same question. An object on a rope is raised at constant acceleration. Which of the following statement is true?
The tension
Hey.
is greater.
As a constant acceleration.
Equals.
Yeah, equal.
They are equal.
B.
حرام عليك يا زيد.
It's raising up.
Not
Oh,
constant
acceleration.
velocity. Not
Acceleration,
constant
acceleration.
velocity, gentlemen.
Oh, acceleration. Yeah,
The
yeah.
tension.
Yes.
So what is here? The tension is greater than the object.
Greater than. Yeah, yeah.
That
So it's
means,
going
gentlemen,
upward.
constant acceleration, there is a net force upward.
Yeah. Oh, yeah, yeah.
If there's a net force, that means T is greater than W.
Yeah, yeah. Great.
See what? But if I change the word into, instead of constant acceleration, into constant velocity,
VB.
they are equal.
Yeah.
At constant velocity here, we say at V constant, gentlemen, we can say yes. Here we can say T equals W.
Yeah.
So F net equals 0. Yes.
Constant here, so you solve it with us. I guess it's wrong. It's saying because it's the same idea here.
We will see. طيب يا شباب. A car is parked.
See.
معلش أخركم يا شباب سامحوني. We try to finish 2 or 3 questions here. A car is parked on a slope. What forces are acting in the car? Gravity, kinetic friction.
Gravity, no
Gravity,
more.
Static
normal
friction.
force. Gravity, normal and static friction.
Yes.
Answer the question.
C.
It is C.
Yeah.
طبعا is it clear why C?
Spark.
Here, kinetic, this is both wrong. It's start.
Yeah.
And normal and static friction.
Yeah.
Okay. Now you are in a train traveling on a horizontal track and notice that the piece of luggage starts to slide directly towards the back of the train. From this observation, you can conclude that the train is
Speeding up.
always speeding up and changing.
Direction.
Speeding up, sorry.
Speeding up.
Yes. Because see, if changing direction, it will move to the
Other
left
side,
road,
yes.
but it's moving here. Now, if we can say the speed is constant, that it remains in the same place.
Yeah.
If slowing down, what happened to the luggage? Move
Move
forward.
Yes.
Yeah, see the question, you can just see. The last question is, if a net force accelerates 5 kilogram, this is here, mass at A. What is the acceleration would be the same, net force give to 20 kilogram. From these two you can find F, right?
Yes.
The same force you can apply for what?
Yeah.
What acceleration? F for M
A.
times A mu, this one, you just A prime.
Yeah.
This is 20. So this is, say, M prime. This is 20. We need A prime. And the force you got from here, you just put it here. Okay? Tell me, this is the whole exam. How is it? Wallah, ya shab, it's easy. We done the exam, see? Nothing there. So your job is to see. This is the idea.